science. Greetings, the Astro 30 here yet again, and welcome back to AEL on this windy Tuesday morning. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Thanks. Sitting up on the desk today, I've got this NVA AP50, NVA AP50 stereo amplifier in for repair, and it's seen better days. According to the owner, see the front panel's all loose. According to the owner, it was dropped, and most likely dropped in transit. There's actually a corner missing out the back panel here, which is just a piece of acrylic. And the front panel's also acrylic as well, but that's not damaged, it's just come away from the two wooden side panels here. The only thing I know about it is, from what I got told, is it doesn't work. I'm not sure why it doesn't work. It's being dicked around in on the inside, but we'll pop you up on the desk in just a moment, and we will take a good look at that power cord's crap as well. Let's take a good look at what's on the inside. Now, this does actually scream, you know, home built here. These are the two power amplifier boards, and they're just floating around in space. They're using TIP141 and TIP146 as the output devices, a Darlington complementary pair, and they're still currently available. I'm not sure what's going on here. This is supposed to be an earth, but it's not actually connected to anything, or the ground, so that should be the ground point, and that should be connected to there. This is not connected, and that's one of the supply rails. Looks like the negative supply rail here, it's not even connected, so it's not going to work. This transistor over here is not actually soldered into its hole, so that transistor is disconnected. And same over here. So on both power amp boards, one of the transistors have been disconnected on either side, which is not going to be very helpful for operation. I mean, this thing really needs to be rewired and tidied up, because this is absolute crap. I have never seen construction like this ever. Half of it doesn't even look original. There's all the input sockets back there with a switch here. These are not the original knobs on the front here, they've been put on after. This one's loose. That's a Allen key. So I'm going to first start off by taking this front panel off, and I'll set that to the tape input. Take this front panel off and get it out of the way so it's not stressing everything. So I need to find what looks like 3mm Allen key. I'm not sure what's going on here. They've put two resistors in series with each other, 0.22s and a 0.22 and a 0.47, to try and make 0.68, because they're actually 3 watts 0.68 over here, and 7 watt 0.68 over here. 5 watt probably would have done. So anyway, I'm going to take these front panel knobs off and take the front panel off so I can, you know, get a better look at things. I'm not sure why there's heat sinks on these transistors here and not over here. In fact, yeah, I don't know too much about it. I'll also see if I can find a schematic for this. I think there is one available. But before I go too far, what I'm going to do is I'm just going to double check these output transistors just to make sure that they're not shorted, because if they're shorted, well, it's basically all over for this. That means I'd have to go out and get some new ones, and I'd have to order them online because, well, I can't get them from JCar. So this one should be an NPN, so it should be positive base, diode junction, no short. That transistor's fine. This is a PNP, so negative base. Diode junction, collector in the middle, no shorts. Oh, hang on, there is a short there. Okay, this one's suspect. I'll have to take him out of circuit just to see what's going on there. But there is definitely a short circuit there. Okay. This one, diode junction, no short circuits, great. And this one over here, diode junction, no shorts, excellent, that's fine. But there seems to be a short circuit over here. So I don't know whether that's the transistor short circuited or what. Yeah, it's definitely got a short collector emitter. So it's most likely possible that this channel is dead. So I might have to disconnect him out of circuit. I'm not really liking how this is wired, it's just absolute crap. Alright, so yeah, let's get this front panel off. This volume pot nut is proving challenging to get off. It's like it's cross-threaded. Yeah, this was probably not the best thing to start working on first thing in the morning. Bitch. All the wiring's broken in here anyway, so I'm not really particularly fussed at what's going to come undone. This is just wired in the traditional fashion. That's better now, it's loose. I just could not get it undone with the pliers. So either Loctite or something. Yeah, there's some form of Loctite there. They've disabled the unsoldered that LED. They've disabled all the locating hardware of pots and the switch here, so you know they just cut them off. It's not the best job, and well, they've got a resist. This is interesting. They've got two resistors across the pot here. So one goes to the ground side, which is not connected to anything, so that's connected to here. And that goes to the input side, so they've got a resistor going to ground on the input side, probably for setting the input impedance. Yeah, there's a bit of Loctite on this. That's why it was so hard to get off. Okay, that's fair enough. That ground should be connected to this floating piece of shit here, which is supposed to be connected to there. I have to unsolder this LED because it's in the way, or else I'm not going to be able to get the front panel off. So yeah, I'm just going to get rid of all this excess crap. It gives me an opportunity to clean this up. This LED looks like it's glued in at an angle. Looks like they just shoved it in the hole. It's a 5mm jobby, but yeah, this is probably the worst workmanship I have ever seen on anything. Not really particularly worried about where positive and negative is at the moment because, well, they've left the lead length on there. So the longest one would be the positive, which apparently goes to ground. So that's interesting. So with the front panel out of the way, I'm going to need to work out. So the collector goes to the negative rail on the PNP side. So it must be a emitter follower output. Probably is. So this is the negative rail by the looks of things. Yeah, because the negative capacitor goes to it, and this resistor looks like it's overheated too. Alright, so I need to find out why this transistor is shorted. So I need to actually unsolder it from the board. And I'm going to start marking things with a pen when I can find it. I had one here the other day, there it is. I'm just going to mark where the positive rail comes in, where the negative rail comes in, just so I know there's no silk screen on this PCB. Okay, so that means I can start unsoldering stuff and working out what's going on. I don't like this, this is just crap. That's one of the outputs. And they go through a fuse to the speaker, which is nasty. And these capacitors are just glued down to the chassis. This is metal. So, alright, I'm going to take this PCB out after I unsolder this mess. It really needs to be rewired, honestly. That's disconnected. That's already disconnected. I need to disconnect that. Bastard. It's not even connected to that either. It's just right. That's left this board floating. Just disconnect this ground lead here, which is absolutely crap. That's one of the inputs. So that's just sort of like, yeah, a mess. Disconnect that out of the way. So now I should be able to unscrew the transistors and pull the board out so I can get a good investigation of what's going on here. So just give me a few minutes. Alright, I've got these unscrewed. That one's stuck. There we go. Move you out of the way. What else am I attached to? I'm attached to something here. Oh, it's glued to the woodwork underneath. This transistor wasn't even isolated from the heatsink. It was just like sitting there, which is pretty bad. Right, now I've got the module out in my hand. I really would really like to rebuild this correctly. I mean, and what I would do is I'd drill a hole in a spare space somewhere so I can actually mount some standoffs so it's actually screwed to the chassis properly, not this woodwork crap. So these capacitors here look like they've melted. I can't remember what these type of capacitors are, polystyrene or something I think they are. But it looks like there's like a chunk missing out of that side. So anyway, I need to figure out what's wrong with this transistor. So now that it's out of the unit, I don't even know if I really want to call it that because it's not the best design. At least we've got one channel that doesn't have a damaged transistor, or at least I think it's damaged, so I'm going to measure it again out of circuit. I've got everything tangled up here. That's pretty usual. There goes my screwdriver. Ah, bollocks. Right. So this is a PNP, so negative base. So we've got junction there fine. It's definitely shorted there, so we've also got a melted resistor. Yeah, great. So what I'll do is I'll just disconnect the emitter lead here, just so that the transistor is like out of circuit, because it may be something else in the circuit that's shorted. So I want to verify that by just disconnecting that leg. Move the hem out of the way so it's no contact, and now that's fine. Emitter's fine. Yep, the transistor is dead. It's got a short circuit on it, so we're going to need a new TIP146 for a start. This Yeah, this looks terrible. So we know what's wrong with this module for the most part, is that it's got a blown up output transistor, so I might have to order some. I can get them from Wagner, but I don't know how much the cost is going to be for shipping. So we know that's damaged, so that needs a new one. Alright, so I might as well look at the other power amp module that's already still in the unit and see if we can actually get something going. Right, I know, I don't know why I do this to myself. First off, this ground strap, for want of a better term, needs to be reconnected. The owner's son was telling me he had a real big difficulty soldering to it, and well, I just soldered to it fine. I've got solder that just dripped off onto the board, which is not helpful. Let's see if I can suck that up. There we go. So that ground is connected for the most part, which should really be going to the, well yeah, if that's on the negative, that should be going to the anode of the LED. This is bad. So that's our input. So I'm going to disconnect this mess. Not worried about the switching or anything at the moment. I just want to test whether or not the power amplifier module still works. That's an output, that's an output. I can always inject a signal in. So the first thing we want to see is, will this power up with this switch here? So I need to make sure that we've got continuity through, fuck's sake, the power cord and the fuse, the switch, etc. to the transformer. So I'll just go across the power plug. Well, we've got some form of resistance there, that's 8, 9, 10 ohms, something like that. So the power switch is on, so down is on, up should be off. Right, the unit is into off, but the measurement's into mega ohms. It's probably measuring across my fingers. So we know that that's safe to plug into something, but I'm going to put it on the dim bulb as usual, just to make sure, because if there's a short circuit on this board somewhere, I don't really want it blowing fuses and stuff. So let me get set up with the dim bulb, etc. Alright, dim bulb set up. Nothing happened there. Oh, beautiful. There's no short circuit there, that's for sure. That dimmed out. If I'd left that other power amp module in there with the shorted transistor, we would have had a glowing globe. So next thing I'm going to do is I'm going to see what sort of DC we've got on our output of this only module that's in there. And I'll also measure the power supply rails. So negatives over this side, positives over this side. Well, according to that, we've got absolutely no voltage at all. That's because that negative's not even connected. I feel like an idiot. So I'm going to have to solder this thing to the power amp module so we can actually get power. Well, the bastard doesn't want to solder, so that'll fix that problem for now. Alright, let's try that again. Still no unusual current draw there, that's good. So now if I measure across the power supply rails, well, we've got 33 volt DC. I don't know if that's right. Well, there's 42 there and only 9 there. Because that's disconnected. God damn it. Right, a couple of test leads later. Okay, now we should have about 80 volts. There we go, 85.4. So that's a plus minus supply rail of 42 volts. So we've got voltage there now, so let's see what we've got at the output. About 100 millivolt DC, which is kind of high, but yeah, it is what it is. So I might clip on some leads to the output and the ground, and I'll just touch my finger to the input connection and see what happens to the meter. Alright, so I'm connected to the output and ground with my multimeter. That is quite a high DC offset, I must admit, but I'll just touch my finger to the input. It is actually changing. Right, so on the millivolt scale itself, just touch the input again. It does appear that something is happening, so that's the blurt test. It looks like we might have one working module, which is good, but those connection points on that second transistor there are getting really close to each other. So, well, we know there's no short circuits. We've got a crappy output voltage, DC offset, which is not much I can do about that. So the next thing to do would be rewire it so that all this crap is gone. But what I was thinking was I'd put it across a dummy load with a input signal and just see if the thing even is working as an amplifier. If it is, well then I can then work on fixing this module up and fixing it to the case better than how it is, because, well, that's just loose. It's not even glued to anything. And then order another transistor for the other side and see what actually happened to that module. But now that we've got one working module, it's pretty good at this point. And I'll work out how to, you know, reattach the front panel and such. So let me get my, what's it called? Thingo, dummy load, and oscilloscope and everything set up, and we'll just take a measurement of the output and see what we get. That would be a no. It looks like we're missing the negative going cycle. So that means the PNP transistor isn't actually doing anything. So yeah, we've got an issue with the transistor. Oh, I know why. I forgot. It's actually still disconnected out of the circuit board. I've got to put the, what are they taking out? I've got to put the base connection back in, otherwise it's not going to work. Alright, I feel like a stupid fool now. With that transistor's base now soldered in, we look up here at my oscilloscope. We now have a sinusoidal output. I mean, it is clipping a little bit at the top, but that's probably most likely because of the dim bulbs in circuit. I mean, it doesn't look bad. I mean, it is outputting power. I probably should actually take it off the dim bulb now, so I know it's safe to plug in, and just see what sort of power output we're getting. At the moment we're getting about 4.12 volt RMS before, because well, it does go a little bit further than I thought, but we are starting to clip unsymmetrically, and then it just totally goes off the chart. It's the dim bulb doing it. So, well, we know that the amplifier is doing something, so there's hope for this yet. I do really need to seriously rewire all this crap, because loose connections and wires all over the place and really badly constructed and all that makes fault finding stuff like this a lot harder. So what I'm going to do is I'm going to plug this directly into the power point and see if we get a better output signal, which we should, because we're going directly unencumbered. So if I turn it on now, still have an output. Still looks slightly terrible, but I can go a lot further in its output. So we have got a little bit of ringing There's clipping there. So we're pushing 43.5 volt RMS before clipping, which according to this is 236 watts RMS into 8 ohms. So that's actually quite impressive. But then we are dealing with a plus minus 42 volt rails. So, well, we know that it's actually functioning as an amplifier. What I do need to do is just hook it up to a test speaker and just, see what it sounds like on the output. But now I've got the transistor soldered in, what I'll do is I'll now measure what the DC offset is with it actually connected. About 39 millivolt, which is a little bit more respectable than what it was. So we've got like about 40 millivolts DC offset there. It still is on a little bit on the high side, but it could probably be better balanced by messing around with the input stage. So we got one working module. I'm not really 100% sure why we've got that weird clipping on the top there. So I guess it would be a good idea now to pump in an input signal into a speaker and just see how it sounds and performs. I've negated all this switching and the volume control here, so that's not going to be very helpful to us right now. So I'm going to have to figure out how to get a signal in easily. Right, I'm hooked up to one lonely little speaker. Okay. Well, there's a little pop when it turned on, not too bad. Well, it certainly is amplifying. I've got a bit of a buzz there, that's only because of my input leads here. So, what I need to do is, geez, that holds a charge for a while. They're 4700 microfarads capacitors at 63 volt, and it's still going. And it's finally dropped out. Right, so what I need to do is hook it up to an audio source now and see if we can get a output.
What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.
It doesn't sound too bad. Sounds like a cat. Doesn't sound too bad, I must admit. I turned it off. So, excuse me, what I'm going to do now is I'm going to get rid of all this crappy wood that's in here that's glued, well, it's supposed to be glued to the chassis, but it's not. Get rid of it totally, negate it. I'm going to drill a couple of holes in the PCBs, or the PCB here anyway, to allow me to put screws in there, like standoffs, so this can be mounted to the chassis correctly. And I'm going to go ahead and I'm going to rewire everything and get rid of all these, you know, fly wires, because this stuff is absolute crap. So I'm going to spend the next hour or so doing that, and then we'll come back once I've actually got a, well, better looking layout here. Right, here's the story so far. A couple of hours later, I have actually got the thing rewired. I've got the boards mounted in properly using some screws, one at the top, one at the bottom. Transistors are soldered in properly. The other module is just sitting in here, but it's not connected to power or anything because it's got a fault, obviously, so it's just in there so the board doesn't get lost. And I just can keep track of things. So what I'm going to do is test it on the dim bulb first, now that I've made a major change, which is rewire it. Nothing unusual. I've got it hooked up to the scope too. Fuck. So I wind up the wick. Yeah, it's going to clip because of the dim bulb, but that's working perfectly. Excellent. The amount of junk and crap that I cut out of it. Look at it all. Okay, well, it certainly sounds alright. I can turn that off now. So now all I've got to do is just fix the other module by replacing the transistor, which is probably all that's wrong with it. I haven't wired in the second module, I've just left it all floating so I can pull this board out straight and just, you know, work on it. I did actually manage to find the schematic for it, which is nice. It's a pretty basic amplifier. They're using BC182s mostly for the transistors, input transistors and all the other stuff. A few current mirrors here and there. TIP31C and 32C as the drivers. I've tested the module that's got the blown output stage. All the transistors test out fine. I have one of them which was giving me a base to emitter junction of about 1.174 volt, which I thought was a bit low, but I cross-referenced it with the same transistor on the other module and it measures the same, so it's probably because it's got a capacitor across it. I actually reckon it's this transistor here that's measuring weird across the base and emitter junctions, or even the base and collector. One of the two, I'm not sure which. Then we do actually have another transistor which is bootstrapped or piggybacked on top of it anyway, so that could be why I'm getting a weird reading. If I pulled it out of circuit, it probably worked fine. Now they're using MM2488 and MP1620 Darlington transistors as the output stage. On the schematic anyway, but in this particular unit they're using TIP141 and TIP146. So I can't find any other problems with the semiconductors on that blown module. So I'm going to safely assume replacing that transistor and a couple of burnt resistors here and there. There's one burnt there. I saw another one a second ago. Yeah, right over here is burnt as well. So replacing those resistors and these ones to get rid of them, put proper ones in. I reckon that this board will work again, no problems. And then I'll work on fixing the cosmetics, like reattaching the front panel and then rewiring all the stuff on the inside so that it can connect to the sockets, etc. at the back. So anyway, I hope you enjoyed this video. If you did, please remember to go down below, like, comment and subscribe as usual if you haven't done so already. And I will be revisiting this later, so not in the not too distant future. So look out for part 2 of this video. Anyway, thanks for watching, and this is Yashro30 saying I'll see you in the next one. Thank you very much.